Hello, this is part 3 of notes 32. We're covering problem 11-7. The problem is iron 3 bromide will react with chlorine gas to produce bromine and iron 3 chloride. The reaction produced 543.6 grams of iron 3 chloride. How many grams of bromine were produced? You'll notice here that we don't have a balanced chemical equation. And again, as we look at the problem and we think about what we've been given and we think about what we're looking for, one of the things that we notice is what we're given is FeCl3, but what we're looking for is Br2. So the only thing that's going to relate these two otherwise not relatable things is our balanced chemical equation. So if we take a look at it, again, chemical naming is huge. We've been hitting this hard all year. Hopefully this is not going to be a deal breaker for you. But we have iron 3 bromide will react, that means plus, chlorine gas, remember that's one of our 7 diatomics. To produce tells me I'm going to write my arrow to produce bromine, another one of our 7 diatomics, and iron 3 chloride. So let's go ahead and see what that reaction looks like. And it's not balanced right now. So why don't you take a minute, stop the video, and balance this equation. Stop now. Welcome back. Let's see how you did. I hope you agree. It looks really good. We've got 2 irons. We have 2 times 3, which is 6 bromines. We've got 3 times 2, which is 6 bromines. Looking at our chlorine, 3 times 2, 6. 2 times 3, 6. Again, my personal recommendation is to extract the information that you're given. So I like to pull things out and write down underneath what it is I'm looking for. And that just helps me stay focused. So one thing this does for me is here's the mole ratio that I know I'm going to be using for this problem. But take a look. What unit are we in? We're in the G unit. Can't be in the G unit if I'm going to use a mole ratio. So we have to remember to get from grams to moles using the molar mass. So here we go. We're going to always begin with what was given. All right, step 2, run the calculation all in one piece. Starting with 543.6 grams of FeCl3. If I've got grams upstairs, I want grams downstairs, moles here. So molar mass is going to go right here. And there's our molar mass. So we have 162.20 grams of FeCl3 for every 1 mole of FeCl3. If I stop right now, which I'm not going to, but if I did, my grams of FeCl3 is going to cancel. If I stop here, I'm in moles. So we're on our way. We're getting on the mole road, right? So now I can use my mole ratio. So I'm going to, if I have moles of FeCl3 upstairs, I want moles of FeCl3 downstairs. Now we're going to have moles of bromine upstairs. This step is stoichiometry right here, using the mole ratio from the balanced chemical equation. If I stop right now, my moles of FeCl3 cancels out. My answer would be in moles of bromine, and that's good, right? We've gotten from FeCl3 to bromine now, but we want grams of bromine, not moles. So we have one more step, and that is to convert from moles back to grams using the molar mass of bromine. So for every 1 mole of bromine, there's 159.80 grams of bromine. And grab your calculator now because our moles of Br cancels. Now, right here, this is what tells me I'm ready to use my calculator because look, it says G unit and bromine. G unit and bromine, that's what I'm looking for. So 543.6 times 3 times 159.80 divided by 162.20 divided by 2 equals. The magic of the computer. There you go. So we have 803.3 grams of bromine.